So I'm here with Professor Misha, and we're going to speak around one of the most popular concepts in mathematics. I mean, popular culture probably knows about it, doesn't really know about it, but recognize the existence of it more than anything else, more than any other constant in mathematics, which is pi. And Misha wanted to speak about it, about the history of it, about the applications, and how it has been fascinating humanity for several millenniums already. Please.
Yes, it's pi is a fantastic number, and even now, a lot of people, a lot of researchers, kind of calculated to the 3,000 number, etc., etc.
Even more, not today with computer, with brute force and computers, they manage to, I don't know, trillions of digits. No, correct me if I'm wrong about
Yes, yes.
And yet there is, and yet there is no pattern. No one recognize any pattern. Or
nobody recognize any pattern, and they say the numbers of pi can have any numbers, any sequence of numbers, your phone number, my phone number, anything. So, and it fascinates people.
It's the monkey on a typewriter theorem, right?
Yes, that monkey, but if you give monkey enough time,
yeah, it's going to be Shakespeare.
It would be Shakespeare's sonnet. Yes, absolutely. But we are not the first generation who are fascinated with the number pi. It started at least with the ancient Babylonians and ancient Egyptians, and also in other cultures like Indian and Chinese. And interestingly enough, I believe this particular knowledge about pi was a very guarded state secret, because the cultures like Babylonian cultures were very cautious to disclose this number to the enemies, because this number was helping people, to build things, to understand their astronomical things, and etc., etc. So it was kind of state secret, like now nuclear secrets or something like that. There are indications that the Babylonians went very, very far with calculations of these numbers. They came kind of the precision of at least 3 numbers after the decimal point, but then it was somehow forgotten, and it was quite a big achievement by Archimedes when he approximated the.
He locked it between two polygons, right?
Yes, that's how actually many people did it later as well. He did it between two polygons, and the upper approximation was 22 sevenths.
22 to 7, yeah, we still use it, right? And you mentioned in the past also that it's the best approximation under 100.
Yes, it is. It is a best approximation under 100. I will kind of clarify what it means. So there are better numbers. So, for example, Babylonians came to the number 355 over 113, which is like 316 over 133. But it's closer to the number of pi, but it is obviously over 100. So for some reason, the 100 is an important number, and it was important to keep it under that number. The thing is that there is a magic of these numbers as well, because obviously number 7 played a very high role in many cultures for many years. We have 7 days of the week, we have 7 colors of the rainbow, we have 7 notes in the music.
And even now when we are counting the Omer, leading, so it's 49, which is 7 multiplied by 7.
Yeah, you count 7 times 7.
Yeah.
And that's very, very important. But 22 also has a lot of importance, again, in different cultures. For example, in Jewish culture, obviously, there are 22 letters in the alphabet, and the Jewish tradition says that the whole world was created through the letters of the Hebrew alphabet. Yeah. So 22 over 7 is quite a good number.
How many digits? Just remind me. What the approximation? How many digits does it give you? 22 by 7. Divided by 7.
22 divided by 7.
If you remember,
I believe there are 2. I think it gives you 3.14 2856, and then
which
repeats.
is probably very good for almost anything that we need, including engineering. I mean, not probably, I don't know if enough to send something to space if you have to
No, it
calculate
wouldn't
bigger
be.
orbits, but it's good enough for any human task. I think most human tasks which are not too
Yes,
exotic, too exaggerated, or too far-reaching. I mean, exaggerated maybe is not the right word to say, but anyway,
I would think the space industry and military industries
probably use
would use better
a better
approximation,
approximation.
but
They would
but
go, yeah.
for us it would be very good. But we should not forget that, and I'm not sure that Archimedes knew that, but I would imagine he did, because this is the upper approximation. There is a low approximation, which is also very close to the number 3.16, 3.14, and normally when we take the approximation to pi, we don't take the upper approximation or lower approximation. We take half of the sum of the two. Yes, and interestingly enough, in the Bible, you find very interesting things, because there is maybe next time I bring it in a quite detail. But there is a part of the explanation of the time of Solomon when he is building the temple, and the number. There is indication, very clear indication how one needs to calculate pi, and it's very close to the number pi. But in a way, it is not said in the Bible clearly. It just through the difference how you read the biblical verse and how you write the biblical verse. For the difference of that, you can figure out what the pi is. Why I believe what is done, again, they didn't want to disclose to everybody who would read the scripture.
And maybe I'm going too fast, but it's very interesting that actually you talk about state secret, and it's true. It was I know about secret societies that existed. Pythagoras was probably the most notable of in antiquity, and one of the first in antiquity. They were actually more interested in integers. I think we spoke about it in the past, not recording anything about it necessarily, but we spoke about. I don't think what their relationship was with pi. But before you answer that, if you know anything about that, I'm just saying that from state secret it became again maybe the most popular or well-known constant or symbol in popular culture, even though most people don't really know what it means or never went into the depth of it. They studied in school, maybe they like the way it looks graphically, I don't know, maybe they use it for tattoos. It's a fairly popular subject, but it's interesting. So today, pi became probably the most well-known constant in mathematics. Why do you think? Is that maybe because circle is such a perfect shape?
Yes, well,
As perfect as we can consider it to be, of course.
well, basically, it is because the circle has the very magical qualities. In fact, we should never forget that circle wasn't kind of invented by people, so that's why we say don't reinvent the wheel. But we, as a humanity, there were times then we didn't have the circle, and in a way, try to go around in the bicycle, for example, with the squared wheels. So
long before it's a bicycle.
yes, I know, or whatever the horses and or even the oxes. So it's been a huge achievement. We should not overestimate the achievement of these things, but we of the wheel. But also, it is not only kind of when we have our carriage and the horses or chariots for the fighting. It's also there is a lot of round shapes. For example, for the ancients, as well for medieval people, as well for modern people, the astronomy played a huge role. So trajectory of the celestial bodies are not quite circular, but the close to the circle. That's
elliptical,
elliptic,
yes.
of course.
Oh, yeah.
But at that time was seen more kind of the circular.
Well, the ellipse is a case. Actually, a circle is a case of an ellipse. No, wouldn't you say?
Of course,
it's a case of an ellipse.
It's taking focal
Exactly.
points together. So circle has a beautiful things like you stand in the middle. It's a perfect. So, for example, people fascinated by symmetry.
Yes.
If you take, for example, a table which is in front of us, we have like a a few lines of symmetry.
Mm-hmm.
The circle has infinite amount of
yes, but you define it by being in the center, and then
Yes.
let's say inscribing a line, and then to the circumference, and everything from the center to the circumference is going to be even, a radius.
Yes.
That's what we call a radius.
You can shift the table, I don't know, 10 degrees, and it will be very different shape.
Yes.
You shift shift the circle
infinitely.
Of course, much later, but Greeks already had certain feeling of this. They saw that the Earth is round,
Mm-hmm.
right? So all this Columbus's kind of discovery of America is predicated on the fact that the Earth is round.
Mm-hmm.
So again, obviously, Earth doesn't have perfectly spheric shape, but quite close to these things. The planets were found because the trajectories were wrong, quote unquote. So basically, this shape always fascinated people. Also, one needs to think it's actually not only the connection with the circle, but many other geometrical figures like a cone, etc., etc. It is connected to the pi. So what fascinated sphere, exactly.
But that's what Archimedes wanted to be inscribed on his gravestone, no, tombstone. He wanted the sphere. He was investigating spheres.
Yes. So, in a way, if you think about it, I was very impressed. I think as 10 years old or maybe younger, when I first understood that the pi is both part of the equation of circumference and the area of the square.
Okay. Yes.
That's already unbelievable, right? Because why should be the same number be included into the into both the square and the perimeter? If we look at for example, I don't know, the triangles or other shapes, it is not like this. But then when I saw about cones and spheres and whatever, it just becomes like a very, very universal number, which is underlying something which is very, very basic for us.
Very primal, very important to the engineering of everything around us, or to our actually a sense of engineering, whatever the way that we perceive the world around us, I believe. This is why pi is so fundamental.
And then also very interesting, kind of it just comes to me in this moment when we talk. One of very kind of late ideas of mathematics, much later than idea of pi or idea of even sine and cosine, is the idea of limit. So this particular sequence in its limit goes to a certain number. But in fact, what you just mentioned about Archimedes, putting the figures inside and outside of the circle,
limiting,
it's a limit, because Archimedes, I believe, had 96 figure, 96 angle figure.
I think that he bumped even into some sort of a primitive version of calculus without even realizing that he was doing calculus.
Yes, well,
if you're already speaking about it,
you're talking about a very, very interesting point, which we probably need to speak about. In a way, a lot of things, and well, we know it kind of a bit subconsciously. That's why the Italians called it Renaissance. Italians, French called Renaissance, to be born again. It was not only in the arts and the literature which people understand, because people were very conscious at the time of Leonardo da Vinci and Raphael.
He was into mathematics, by the way.
Exactly.
I don't think Dürer, Dürer, the painter,
of course.
he was, I think, much more involved in mathematics than Da Vinci, but Da Vinci was into mathematics as well, apparently, not just an engineer.
Yes. So basically, not only cultural things like philosophy and literature and you name it, was kind of birth again of the Greek culture of the ancient time. Mathematics, astronomy, everything was rediscovered in the 15th century. That's why it's actually not a coincidence that, for example, Columbus was in the end of the 15th century when they rediscovered the ancient Greek texts and translated into Latin and more popular culture. But the same things, astronomy, of course, very much based on the mathematics. There is no astronomy without mathematics. So mathematics was rediscovered in the 15th, 16th, 17th century. In a way, fortunately or unfortunately, mathematics was probably a little bit lagging behind of catching up with the ancient thing. we can research that and look at this, because from the scientific shapes and form, from the artistic shapes and form, 15th century, 16th century, they went sometimes beyond the Greeks. What you mentioned, the calculus, in a way, Greeks were, in calculus terms, Greeks were superseded by the modern scientists like Leibniz and Newton, only towards the end of the 17th century.
Yeah, it took a lot of time, yes.
Which is fantastic. In fact, again, one needs to research. We all know about Julian calendar and Gregorian calendar and discrepancy. And this, many people know it, I think it was 1584 when the Pope Gregorius, changed the calendar. But there were ancient systems like Hebrew system, probably some other systems, which were more precise than Julian calendar in antiquity.
No, that I agree, that I understand. I go sometimes to the writings of Archimedes, Euclid, and the contemporaries, not contemporaries of people who preceded them, and around the golden age of Greece. I think there was nothing like that in the history of mathematics when it comes to how many great mathematicians lived in that around that region, around that time. But I want just not to digress too much. I wanted to say, actually, I'm continuing from your point into the days of Euler, Leonhard Euler. And he showed pi in a place where many people were surprised, or maybe they should not be surprised about it. You remember the buzzer problem?
Yes.
And this is where he came to the conclusion that the sum of the series is going to be pi to the power of 2 divided by 6.
Oh, yes.
You remember?
Of course, and pi as well.
Yes,
interesting.
It's
enough,
very,
right?
that's why, yeah.
18th century, yes.
Yeah, I wanted to speak with you about it because he was a student of the Bernoulli family, right?
Yes.
They were tremendous mathematicians.
Yes.
And they had the puzzle problem there, and they said, okay, someone need to solve it, and he is at the Thunder Age, I think it was 28 or 29 when he solved it. And he came to the conclusion that the sum was pi to the power of 2 divided by 6. He said something fascinating. He says if I take a circle with the diameter of 1, so it means that I have like this, the square of the circumference of a circle divided by 6.
Right.
It's incredible. What do you think about it? I mean, should people? I got my own ideas about it, but I want to ask you: should people actually be surprised that pi suddenly appears there, or not?
I think not, because
I agree. By the way,
it's even the fact which we mentioned. The pi is so fundamental, both for two-dimensional figures, bodies, and for three-dimensional, which is kind of, look, if just somebody walks in and said, who understands mathematics, but for some reason, for strange reason, doesn't know about pi, said, why should be? You need to look into depth of this thing. So pi is the number which is very much in the middle of the how universe was constructed.
Yes, I agree. I think I can make sense out of it. I'm not an expert on series. I love mathematics, as an amateur. And I remember walking once in the street, and it just hit me. It made so much sense when I was thinking about the buzzer problem. And I said, I'm not surprised about it at all, but I guess it was just an incredible discovery and a joyful discovery for mathematicians. In a way, it maybe confirmed something that they already understood without having the evidence, but then they had the evidence, or at least that particular evidence. There is another thing I would like to speak with you about relates to Euler, because Euler was probably the most prolific mathematician, I think, in history. Paul Erdős. He was the most prolific but by collaborations. He collaborated with mathematicians. So if you think about single mathematician, I think is the most prolific probably Euler. And we know the Euler identity. Do you remember the Euler identity? E to the power of pi multiplied by I plus 1 equals 0. Right. Another time. And that actually was a derivative of well, I won't ask you about it, but just to remind, that was the derivative of the Euler formula when he actually dealt with the trigonometry and complex analysis, I believe we call it, right? That he was actually started with I to the power of x e to the power of x multiplied by I, and then cosine and sine, and then he started relating the complex number with trigonometry, and this is how from that he came to the identity. What do you think about it? Pi again. It makes sense because it's trigonometry, but yeah, I would like to have a thing.
Yes, well, this probably requires a separate session
Okay.
because the numbers which you mentioned, they are coming from very different parts of mathematics, and still they are part of the same identity.
Exactly, amazing.
And again, one of the things with the pi and why it's very important with the pi, it kind of tells about the unity of the universe, and also deep on the philosophical and maybe spiritual level, which is very important, I think, mathematics. Mathematics takes you into this idea, which was shared by, in my mind, two greatest physicists of last millennia, Isaac Newton and Albert Einstein.
Isaac Newton.
Yes, who saw the creator inside of of physics.
I agree with you.
And there is a lot of quotes from these things. In fact, Newton saw his spiritual endeavors, understanding creator, understanding the world, as a higher contribution to the society than his physics. And
he was a very religious man. I spoke with the rabbi about it. We had a podcast about it, and not just about that, but we mentioned it. He said that his greatest achievement was some sort of a commentary that he wrote about Saint Augustine, the vision of Saint Augustine. That's what Newton said. And by the way, John Napier, logarithms, he said the same. Both of them are very religious people. I mean, come from a different time, but it's fascinating. For me, mathematics, I have to say, sorry, I don't want to drop you out of the subject. I'm just saying, it's a form of, it's such a metaphysical thing. It's so close to this spiritual affairs philosophy, of course.
I think the topic of our series, I hope, will be more like looking at how mathematics is a part of the general creation and how it is close to
That's exactly why I like it.
Yes, because again, it's kind of my very, very deep conviction. So what if we look, and I love history, and I love history of mathematics, history of science, and history generally speaking, because when we look at mathematics or physics, it's very easy sometimes to take and forget the time when it was created, and it shouldn't be done because everything needs to be seen in the context of the time. So if I see the history, how I see the history, that in the ancient time, people didn't use science very much. The problem, from our modern point of view, I think one of the Christian theologians, I will look up who it was. He said that the philosophy is the servant of theology. So basically, for many people of the Middle Ages, and for the priests like from ancient Egypt and Babylonia, the science, the physics, the mathematics was part of their theological things.
Yeah.
And at some point,
Euler started it with the theology studies. It's only because of the Bernoullis that they convinced his father, look, this guy is just too good for mathematics. I mean, he's too good as a mathematician. Please let him do it.
Well, Tesla, by the way, I recently read, he was dying because his father was a priest and wanted him to be a priest. His grandfather was a priest, and he was dying, and only on his deathbed, his father, something like this, his father said, "What do you want?" I said, "Please, father, release me from the theological theory." Nothing wrong with theology; it's a great thing, but there is kind of rebellious feeling, and we kind of grown up on these things because this story about the Catholic Church didn't force Galileo Galilei, of course, everybody.
Yes, I read it, but it's I think this is a completely different subject, but it's fascinating. I think it's a very twisted view that fits. I mean, it's not that it's incorrect, but me growing up as a 10-year-old, let's say, reading encyclopedias and discovering Galileo Galilei, Copernicus, and some other people who were involved in astronomy and had a lot of struggle against the Catholic Church. And you could see it was for me almost like projecting on everything, including us, Jews, because I grew up in a secular place. So for me it was, okay, you see, this is the biggest enemy. See, religion is the biggest enemy, or God, whatever you want to call it, the biggest enemy of science, of free thinking, which is not correct. I don't agree with it. That's a different subject.
Yes, exactly the same thing. I was born in the Soviet Union, and then even after the collapse of the Soviet Union, the scientific community is very much kind of teaching the Catholic Church, and by extension everybody else, all kind of religious people, religion is kind of here to suppress science, to suppress free things. But it happened in the past, but it doesn't have to be that way, because apparently what I read, that the Catholic Church based their opposition to the idea that the Earth is going around the Sun on the biblical part of the judges of the Shoftim, that Joshua said to the sun, "Stop the sun! I need to take over Jericho." So it could be poetic from the biblical point of view. It could be, look, maybe he stopped the earth rather than stop the sun. So we don't know. So we can't put, in my humble opinion, we can't put this biblical verse as a scientific proof that the earth going around the sun.
I think it helped a lot the scientists of the days of the back then, that they came up from this background. I mean, sometimes it worked against them if you speak about Galileo Galilei, but I think overall, from philosophical point of view, and because it was more, I don't even like the word science. Not that I'm against science. I like more natural philosophy. I prefer to look at it like that. But you look at the world, even if you're a scientist, you look from a philosophical point of view. For me, Newton was a natural philosopher. And that's brilliant. I think that it helped him a lot, and I believe that Descartes came from that background, and Pascal became very religious. You know, Pascal was one of the greatest talents in mathematics.
Pascal has a. In fact, he used. I believe he used the mathematics to prove why he would like to become religious. Do you know the story?
I've heard something actually.
So basically, he said that something like this, that mathematical that kind of, it was a bit kind of yes or no, like binary. Either there is God, and then the reward for good behavior is huge, or there is no God.
I think, but okay, Pascal or Descartes? Descartes.
I thought it was Pascal.
I don't want to argue about that, but I remember reading Descartes.
I always thought it was Pascal, because my understanding Pascal
it could have easily been, you know.
Yeah,
but I think Descartes. Yes,
it was Descartes. Okay, but the idea is still fantastic.
I read it once somewhere, some few years ago. So it's brilliant. But I don't want to stop. But I want to ask you about the Euler identity then. So you see pi there.
Yes.
But you said, do you think it's a bit too difficult to explain it now because it has to deal with complex numbers or complex analysis, or is it something that you can?
I think it's quite difficult to explain because it takes complex analysis, and quite different part of mathematics than, for example, what we mentioned about the ancient ones. So Euler, of course, was a genius, and he came and he connected different sciences.
Amazing, yes.
But this again gives us a proof that the universe is united as one, and also kind of it's based on some very simple principles. Again, it reminds me a very interesting quote from Einstein, that every system needs to be as simple as possible, but not simpler than that. So somehow fantastic, isn't it? Because and I saw certain kind of research, certain PhDs, when people try to explain things through very, very complicated mathematics. If you look again, both at Newton and Einstein and at Euler, they explain very, very complicated things by very simple
that's true
formula,
and beautiful. That's the beauty of it. You know, it's Paul Dirac, a physicist. He said a formula. I think an equation, if it's beautiful, it will work. If it's beautiful, it will do the job. You know, it will work. It will stay. If not, it won't. It will perish. Fantastic. It's true, because Euler's identity is beautiful. Not just that, some other things. But as you said, simplifying things, taking incredible concepts, like taking so many different parts and organs of mathematics and just connecting them with such a beautiful, fairly short. It's a very short identity as well, formula, whatever it comes from formula. It's wonderful. I agree with you about it. But okay. So
yes, because in order to do this, by all means, we should do this. But before that, we need to kind of to speak about the complex numbers.
Okay, so we don't need to do it now. But I'm not, by the way, trying to speak too much about Euler, although he always deserves as much recognition as possible. He is incredible. He's one of the greatest geniuses, period. Not just in mathematics,